This simulation is about electrostatic comb drive based sensor and actuators. Electrostatic comb drive is popularly used drive configuration for actuation and sensing in micro electromechanical system. During this simulation, force is used as input and equivalent stress as output. A force is a push or pulls upon an object resulting from the object's interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the objects. Equivalent stress are calculated using a theory that matches our material's behavior in ANSYS. There are two different forces applied during the simulation, which are 200 Newton and 400 Newton. For the input of 200 Newton, the output was 5.2518 Pascal. For the force of 400 Newton is 5.2182 Pascal. From this, we can conclude that when the force is increases, the equivalent stress is decreased.
So my title is on MEMS electrostatic comb drive base sensor and actuator. So my input is a line pressure. Line pressure is a specification of a maximum pressure that can be applied to both ports at the same time. So the red color one is the place that I put line pressure. As output, I use equivalent elastic strain. The elastic strain can be defined as a pressure limit if the object returned to the place where the charge is removed or deleted. The yellow color label is a place that we can see the changes on the design. So there are two values tested to this design as a line pressure 20 Newton and 40 Newton. For 20 Newton, this output is 3.388 millimeter, and for 40 Newton is 3.406 millimeter. So as a conclusion, when the line pressure is increases, the equivalent electric strain also increases.
My title is on MEM electrostatic comb drive based sensor and actuator. In this project, the simulation and analysis were carried out on the pressure input and the normal elastic strain output. The comb drive actuator contains two solid material which are structural steels and stainless steel. There are two values were used as in pressure 20 pascals and 50 pascal to test with the output normal elastic strain. The maximum pressure is 50 Pascal in 1 second is applied to the red end of the comb drive actuator. The directions of the pressure is in x-axis direction. As a conclusion, the result of the deformation shows that the pressure will increase due to the decreases gap distance between the plates. The normal strain happens when the elongations of an object is in reactions to normal stress, for example, it perpendicular to a surface. However, when an object is defined by a larger elastic modulus value, the stress effect is small.
Good day everyone. As for my part, I have done the simulation by varying one of the input, which is acceleration, while the other inputs such as force, pressure are kept constant by giving a value of 200 Newton and a pressure of 50 Pascal. So as can seen from the table and the graph, we can conclude that when the acceleration increases, the total deformation also increases. This is because the deformation is the effect of change in size of the material. So we can see that the deformation of an object can be varied by changing, either increasing or decreasing those factors. Besides, the deformation also changes depending on the type of material we use. Therefore, deformation of an object can be observed by studying the effect on the stress and strain. There are several factors encountered during the simulation on static structural. As the load of the design increases, the more the stiff and the material with high Young modulus material. The bulk and shear modulus similarly define material deformation owing to constant volume and different forces. In the simulation and study structure, the finite element approach is used an efficient method. Thank you. That's all for myself.
MEM electrostatic actuator in fight against COVID-19, IoT system, sensor and actuator. Our main device that we design is meant to assist with the pandemic situations of COVID-19. Sensors are the source of the IoT data. A better term for a sensor is a transducer. A transducer is any physical device that converts some physical phenomena into an electrical impulse that can be interpreted to determine a reading. Another types of transducer that we encounter in many IoT systems is an actuator. In simple terms, an actuator operates in the reverse directions of a sensor. It takes an electrical input and turns it into physical action. A sensor may collect information and rotate to a control center where a decision is made and a corresponding command is sent back to an actuator in response to the sense input. And this device applicable to almost any location, utilized in shopping mall, shop lot, hawker store, not to mention houses as well. It helps to utilize for temperature detections of an individual and notify whether the individual is vulnerable based on the sensor information. At first, the temperature sensor detects body temperature. Then it sends this detect signal to the control center. After that, the control center sends commands to the disinfectant smoke. The disinfectant smoke turns on and spray out. That's all from us. Thank you for watching.